Hi, I'm David from Rotorgeeks, and today we're going to build something. I couldn't help myself on that one. Welcome to Rotorgeeks. Today we're going to build a new frame called the Stick. It's one of a whole bunch of new frames that we've released. We've got some for 22 size motors. The Stick is sized for 1407 motors. It's based on 5mm thick arms, and it makes for a very strong, very light, and nice build. Let's take a look at the components that I've chosen for the build today. First off, we've got Rotorgeeks 1407 4000 kV motors. Because we're going to do the 3-inch machine, I thought it would be best to go for the highest kV that's available. We're going to use the FrSKY XSR. I'm an FrSKY radio user myself, and the XSR is the smallest receiver that provides telemetry. For control board, the Rotorgeeks SSD, and for an ESC, all of the stick arm builds really are much better if you use a 4-in-1 ESC. It keeps the profile of the arms clean. So we'll be using the Cicada 20 amp 4-in-1 ESC. And this, of course, is the Stick. For FPV gear, the Stick fits a standard full-size camera, so we're going to use the Rotorgeeks PZ Mini. This is the one that consistently seems to test out with the best image, and we're going to run a 2.5mm lens for a little extra wide view. For antennas, I've got a TVS Triumph, and for video transmitter, I've opted to go with the FX799 transmitter that has a pigtail on it. It's very light, it's under 10 grams, and the pigtail makes it easy to wrap around the frame and secure the antenna on top. And this transmitter for us has kind of been our staple for probably almost 2 years now. It's very reliable, it runs cool, it's nice to be able to see your band and your frequency when you're changing channels, and it has a built-in microphone, so if you like to listen to your FPV, you've got that as well. Let's get started with frame assembly. First, we'll take the battery plate and 4 of the long screws. And number 4, place it down on the ground with the screws facing up. The battery straps, the slots are on the side, so our battery is running this way, so that's front and back. Placing the arms on now, the 3 holes will always face the front or the back, so not the side. That arm goes on that way, this one that way, like that. Number 4, like that. You can now take the bottom plate, just place it on top. Doesn't matter which way you go, since front and back are symmetrical. And then we can take our spacers and just hand tighten those on. And you don't need to grab them with a wrench either. Once they get a little bit snug, we should be able to just come in with a screwdriver on the other side, and they will grip. Okay, so that's our base. So next up, we're going to mount the motors. We're using Rotorgeeks 1407, in this case the 4000 kV. So this spacer is used in between the carbon and the motor, and it both keeps the screws a safe distance away from the motor windings and provides vibration isolation from the motors. You take a TPU mount, you can place it over the holes, and take the supplied M2 by 8 motor mount screws. You can just pop one through and then find the thread for one motor, get into them. It's the same size head that comes with the standard motor mount screws. So just get one on there loose, find your way to one of the other holes, make sure everything's lined up properly. I'm thinking that maybe with the TPU mount in there, that we're going to get enough compression that the thread lock won't be necessary. I just kind of screwed it down until I felt it was compressing but not crushing. And now I'll go ahead and mount the other 3 motors. So I've just finished putting all 4 motors on. Now I'm just going to grab a piece of tape and tie those wires down. If you haven't figured it out yet, I think I'm going to go with the theme of blue on this machine. And I just happen to have some blue electrical tape. So I'll just cut myself a couple of strips, tie those wires down to the arm, and then we will move on to electronics. Next, we're going to move into the electronics. It's a pretty conventional build, except that we're going to be using a 4-in-1 speed controller. Now, the 4-in-1 speed controller is great in terms of reducing clutter. You don't have ESCs on the arm, so it's super for the profile. But when you're using a 4-in-1, you also tend to not use a power distribution board. So we still have a couple of devices that will need some power. We're going to grab power from the 4-in-1 itself. You can see the main leads coming in there. We can either tap power there, or we can pick it up from the pads on the bottom side. The things we're going to need to power are the flight controller. So the Rotorgeeks SSD takes direct battery power input. And we're going to need to power the FPV system, which again takes direct battery power input. So both of those things are going to have to tie down into the 4-in-1 main power leads. All right, let's clear the table and get to some soldering. As I mentioned, there are two pieces of electronics that we want to feed direct battery power to. We've got the video transmitter and the control board. Now for the video transmitter, Rotorgeeks sells a cable that has been customized for this that fits directly into the camera. So we're going to be using that cable because it makes life easy. This is the power for the video transmitter. So what we're going to do is we'll actually just disconnect that cable, and we're going to give this power wire a snip. So let's just cut that off. And this insulator is thin enough that you can usually just strip it away by giving it a little pinch. The other set of wires that we're going to use is just straight wires to power the control board. And I think we can probably get away with just using the half that we didn't use from that wire, because these are nice silicone wires. So we will do the same thing again. We'll just strip away those ends, tin them up, and join them. And then we'll connect them to the control board. Just going to give these wires a quick little tin and put a little bit of solder on the pads that we intend to connect them to. Well, I knocked that one off while I was soldering the other side, and I'll attach that later. It's just a quick little tack. And reattach our main lead. I put reading glasses on to solder, and I can't totally see what I'm doing here. I can't see what I'm doing. I mean, I sort of can see, but not in a way that you wouldn't want me doing brain surgery. I'm not putting the old man glasses on for soldering right now. I'm not ready for all of that at once. It would really help if I could see. Oh. So here we've got our video transmitter cable, and the power for that is just tacked onto the back, ground and positive, and at the same time we've got another set of leads tacked onto the same spot, ground and positive. This set we are going to solder onto the control board because the control board takes direct battery power. To finish off the ESC, we're going to put a battery connector on it. Probably should use an XT30 connector and XT30 batteries, but I already have a whole bunch of batteries with an XT60 connector on it. I found a long time ago that it's much easier to solder an XT60 connector when you have the matching connector inserted into it, because a fair bit of heat goes in here and this plastic tends to melt. So if you just plug the other end in first and then put that into your jig or whatever it is you use to hold the XT60. So there is one little added complexity when using a 4-in-1 ESC, and that is the way that they've laid out the motor numbers on the ESC doesn't match Betaflight. So Betaflight always asks that if this is the front of the machine, right here, the long part, then this is motor 1, that's motor 2, this is motor 3, and that's motor 4. But if we lay this 4-in-1 ESC down, we find that those numbers don't actually match up. So what we want to do is we want to take a look at each one and figure out which color wire will take us to the proper motor connection point. So this is our motor number 1. If I look down here, I see it labeled as 2, and number 2 happens to be the purple wire. So number 1 is purple. And if we go around the rest of the board, you'll figure out that the motor color order is as you see on the screen right now. So this row has the motor output pins on it. The signal is always carried on the top row there. Ground is always carried on the bottom row. And for the most part, this row is nothing. It has the potential to carry 5 volts, but that's not something that we need in this situation. So motor number 1, signal is up there, 2, 3, and 4, and then we're just going to have a single ground connection for everything. 4, green, 3, orange. Number 2 is yellow. And number 1 is purple. And finally we can tie in a ground to anything on the bottom row here. It doesn't matter which one we choose, they're all the same. Next we're going to take care of the receiver, which is the XSR. So once again, for sizing, I'm going to be placing that receiver down on the bottom underneath the 4-in-1 board. Flight control board will be above that, so in terms of length of wire, it's looking like I need to reach over to the front of the board. So let me give that a snip. And we were not going to be using the green wire, the CPPM wire. So we can go into the connector and remove it, or we can not worry about it and just give it a little cut. The more connectors that are on there, the better the physical securing of the plug. We'll remove that and attach it onto the control board. Each of those pins is clearly marked. We've got a ground connection right over there, power in the middle, and then signal, and our telemetry will be connected to that pin over there. So our control board is all finished up now. The only thing left to do is connect the power leads that we left from the 4-in-1 ESC. So power leads coming off of the 4-in-1 ESC are going to be connected onto the terminals marked BAT, plus and minus. All right, we're just about done with the electronics. The last thing we have to do is solder on the motor wires to the ESC. In order to do that, we have to start putting this thing together. So the very bottom layer is going to receive the receiver, the XSR. So let's get that stuck on with some double-sided tape. The Sunrise ESCs tend to come with a little bit of plastic over the holes, so we will have to just clean that up in order to get some screws through it. So we're going to put the ESC down in place. We're going to use some screws to hold it temporarily. There will be more spacers and screws coming on later, so this won't be the final set. just 2 screws will be good. Let's now take a look at the motor wires. I'm going to leave my wires a little bit longer because I might try this out as a 4-inch frame as well, and all I have to do on this frame is swap out the arms. So I'm going to tuck a little bit of extra wire underneath and we'll give it a cut. And we'll do that for all 4 sides. Now with all 4 sides cut, I'm just going to do the same, pinch a little insulation off and get these things soldered up. And finally, we're going to prepare the solder pads. I'm just going to flow a little solder onto each one. Makes it much easier to make the connection later. If you haven't done this before, it doesn't matter what order you put these wires in because we have the ability to control motor direction. So from here we're going to put the stack together for good. So we've removed the screws, the control board is off. You want to take a look at where your antennas are running. I tend to like to run my antennas just along the side of the arm like that. So we can now place the control board down. The Cicada ESC comes with an assortment of hardware. In this case, the thing that we're going to use is these little spacers. They're not threaded, but they happen to be just the right height. They can go on top there. And then we can place our control board over and use a 10mm screw that will go through the spacer, through the board, and into the spacer at the bottom. So we'll just tighten that control board up and plug in our receiver. This is the cable coming off of the control board that we wired up for the XSR. And in there is the receptacle for this connector. So let's get that connected. And then one more connection, the control board to the ESC. I forgot, I was originally thinking I was going to pass those wires underneath, so I think I will take a redo on that one. Back. On the base of the machine, we've got a couple of slots there that you can use to tie down your battery wires. With a 4-in-1 ESC, when you're hanging straight off of the end of the speed controller, you really don't want to do a whole lot of tugging on the end of that battery wire because it is possible to damage the pads and then you've ruined your ESC. So what we're going to do is we're just going to throw just a little loop in there, and we'll feed a zip tie through the bottom and grab those power wires so that if there is a tug on them, it will be all on the connection point with the zip tie and not directly on the ESC. So next up, we're going to put together the FPV side of things. It's all going to be mounted on the top plate, and the connections are to the transmitter and the camera. So we have our FPV camera. This is the standard Rotorgeeks PZ Mini, and we're going to use the metal bracket that comes with it. You can mount the camera on the bottom or on the top. You'll get more angle out of it if you mount it on the top, so that's where I'm going to go right now. So the bracket goes on, screw goes through the bottom, and lock nut at the top. Now, if you plan on mounting an antenna in some off-center way, it's worth noting that the top plate has 3 grooves in it meant for putting a zip tie through. You'll notice that they actually favor one side, so we've got a pair in the center and then one off to the side. That's because some video transmitters tend to put their connection out on one side. So it may matter to you whether you decide if your top plate is going to go this way or this way if you're planning on running something along the side. In our case, I'm going to be running a cable up to connect to the antenna and running straight out the center, so it doesn't matter which way. I plan on tying it on like that. So we're going to attach the video transmitter onto the top plate now. Let's get that on. All right, looks good. Next we can pop the camera in. So the middle holes will be the right spot. And the screws that came with the camera can be used to snug it up on the side. So that's your maximum angle when you top mount. I forgot that I needed to put that cable through first. Let's see if I'll get away with it this way. I actually had to go around the camera bracket. And yes, okay, that's what I needed to do. And attach the antenna, another zip tie. There's our FPV top plate. Camera connection. UTX. You don't need a lot of tension with these nylon. You can definitely strip them out if you over tighten. And now let's put the last 4 screws in. All right, that's looking good. We still have our antennas that I had left out, so I think I'll just tuck those in with the arms. Just peel back the tape and put it along the side. Tuck it on the side. Rewrap it. And now for the final piece of blue. I've really been looking forward to these. They're the new Racekraft 3-inch props. Well, I really like that. Let me know what you think of the color scheme in the comments. Next thing we got to do is get to setup. Of course, I have the props on, but that's just because I really wanted to see how everything looked in blue. We don't do setup with props on, so let's ditch those. I'll be back and we'll do setup.